There we go. Okay, so we're going to find the inequality with the graph shown below here. So what do I see here? My order pair here is, this is my y-intercept, and it's at 0, 6. And then I got this order pair here at what, 6, 7, 8, 8, 0. And I need to find the inequality with this graph shown. We're going to write boundary line for this equation, or this particular graph. So again, I found the order pair where it's crossing the y-axis and the x-axis. So if I wanted to find the slope of this line, which we could do it by using, you can count it from the y-intercept, or we can say, okay, our slope is equal to the change in y, which in this case here, we have a, what is that, a positive 6. We have 6 over, oh yeah, sorry. This is first order pair. This is second order pair. Let's do it right. 0 minus 6 over 8 minus 0. Okay, so I got a negative 6 over 8, and this reduces by 2. So 2 goes into 6 3 times. 2 goes into 8 4 times, and it's a negative slope. So, and it makes sense because it's falling left to right. So my slope is a negative 3/4. We know what the y-intercept is, so I can write it in slope-intercept form. We don't have to do no extra work. So now I can write this in standard form. Let's write it in standard form. What is standard form? It's ax plus by is equal to 0. So I need this here to be on the other side. Since it's negative, I'm going to add it. So now I get 3/4 x plus y is equal to 6. I need this to be a whole number. As you can see, a is a whole number, not a fraction. So I'm going to multiply by the denominator. And what I do to one part, we have to do to every. So now I got 3x plus 4y is equal to 24. It's written in standard form. And now what we're going to do is we're going to write it as an inequality. Okay. Well, this here, they already shaded it, and they said this bottom half is what makes it true. So I'm going to take this, and let's figure out which one is the true one. I'm going to set it less than or equal to 24, and let's just see if this inequality sign is correct for this equation. So the origin did not fall on there, so let's use it. If I put 0 in for x plus 0 in for y, I get 0 is less than or equal to 24. So it's true. So this is my correct equation for this one. So again, we're just checking for points that makes it a true statement whenever we work with inequalities. Okay, so let's do our next example. So our next example says we have a concrete promoter wants to book a band of, or excuse me, a concert. Promoter wants to book a band for a stadium concert. An admission ticket to the stadium playing field will cost $125. A ticket for the seat in the stands will cost $175. The band requires a minimum of $700,000 in ticket sales. How many tickets of each type must be sold to meet the band's guarantee? So we're going to write this as a linear inequality, and we're going to draw its graph. So here we go. What we need to do is list our unknowns. So I'm going to let x equal the number of tickets sold for playing field. All right. I'm going to let y equal the number of tickets sold for seats in the stand. All right, so now that I've done that, I go back, and this is the playing field. So 125x plus the stands, 175y. And I'm going to say it's got to be greater than 700,000. Why am I saying that? It's because they said the minimum, the least amount that band can take or is willing to take in order to perform is 730. So that means, I'm sorry, not 730, 700,000. So in order for that to happen, I know my number has to be equal to that or exceed that. So I got my equation right here. So the next thing I want to do is I'm going to want to graph this. So what I do see is, what if I divided all this by 25, right? So what we're trying to do is we're trying to get this down to where we can graph it on the line. So we can use the 3-step approach that's in our notes over this section. So I'm going to look at this first. I'm going to reduce it. I'm going to divide it by 25, get it on a smaller graph. And when I do that, I get 5x plus 7y is greater than or equal to 28,000. So when I did that, now I can graph this. So now we can graph this as, let's plot our x and y intercepts. And if you wanted to, you can mark this in thousands since we got the number down a little bit better. So we can go, what, 1,000, 2,000, 3,000, 4, 5, let's write 5, 6, 7, 8, 9, 10. All right, so now, and you could have left it with the big numbers, just make sure and make your graph big enough for it. And what I'm going to do is I'm going to pick some points and start solving. And I mean, I'm going to shade it and stuff, but I got to, first things first, find where it crosses the y and x axis. So I'm going to look for the x axis. I'm going to plug in 0 for y, so that gives me 5x is greater than or equal to 28,000. And when I divide by 5, right, when I divide by 5, we get 28,000 divided by, we get 5,600. So x is greater than or equal to 5,600. So I know somewhere is about right, a little bit over half. It's going to be here. Let's do the y-intercept. So we're going to plug in 0 for x. So I get 7y is greater than or equal to 28,000. And we're going to divide by 7. So the 28,000 divided by 7 should give me about 4,000. Yeah, 4,000. So I'm going to say right here. So when I draw my line here between these 2 points, I need to determine which part I'm going to shade that makes the inequality true. So I'm going to pick 0, 0 for that order pair just to check it. When I do that, it says 0 is greater than 28,000. So we know this is not true. This bottom half is not a true statement. So any number I pick above the line right here will give me a true statement with this inequality.